If you rewind the clock 3 billion years, the ocean is warm, murky, and largely empty. You won't find fish, coral reefs, or shells. All the action happens at the microscopic level. The seafloor is blanketed in a grayish mat of bacteria and algae, a living carpet of microbial slime. This ecosystem functioned entirely without violence. Organisms absorbed nutrients from the water or captured sunlight from above. Nothing chased anything else. No brains to plan a hunt, no eyes to spot a target, and no teeth to tear flesh. For the vast majority of our planet's history, survival was a passive state of existing. Life was a quiet accumulation of energy, completely free from the struggle against other creatures. Then, roughly 540 million years ago, the fossil record abruptly fills with complex, strange body plans. Biologists call this the Cambrian explosion. The driver of this sudden diversity was the terrifying new invention of predation. This was the moment that biological warfare began in earnest. Once animals developed muscles and appendages, they gained the ability to move with directional intent. You could finally go to where the food was, catch it, and consume it while it was still breathing. This single shift turned the ocean from a peaceful void into a high-stakes theater of war. For the first time in Earth's history, one animal looked at another and saw a meal. If you are prey in this new ocean, you face a sudden, terrifying crisis. You have limited options. You can try to run, you can try to hide, or you can grow armor. Trilobites pioneered the withstanding strategy. These early arthropods developed thick, segmented exoskeletons. When threatened, they could articulate those hard plates to roll into defensive balls. This biological armor was a massive success. Trilobites spread across the ancient seafloor, thriving in huge numbers and varying sizes, dominating the bottom of the ocean for hundreds of millions of years. Growing heavy, energy-intensive plates was a steep evolutionary tax. Prey species paid it gladly to survive in a world that had suddenly turned hostile. Armor works perfectly, right up until something evolves a way to break it. To crack open these new defenses, hunters were forced to develop overwhelming size and offensive biology that had never existed before. Enter Anomalocaris, the first true monster of the Earth. In a world where most animals were measured in millimeters and centimeters, Anomalocaris stretched up to a full meter long. It hunted using 2 stalked compound eyes. Each contained up to 16,000 individual lenses, providing a massive visual advantage. To catch targets, it extended spiked appendages, pulling prey into a circular mouth of overlapping plates that squeezed inward like a mechanical shutter. Anomalocaris was a terrifying proof of concept. It proved the ocean could support a massive, active hunter, establishing the apex predator niche that would dictate survival in the seas forever. Because the stakes were suddenly life and death, the Cambrian Ocean became a desperate biological laboratory, testing wildly different configurations of mass and muscle. This extreme pressure produced bizarre experiments. Opabinia rippled through the water with 5 stalked eyes and a long, flexible proboscis tipped with a claw. Hallucigenia defended itself with rigid, outward-facing spikes. The sheer desperation to eat and to avoid being eaten forced life to rapidly evolve central nervous systems, complex vision, and articulated limbs. Complexity wins when something is actively trying to kill you. These strange creatures were not evolutionary mistakes. They were the inevitable, extreme solutions generated by the world's first biological arms race. Eventually, this wild experimentation stabilized. The highly inefficient body plans quietly died out, leaving no descendants. The designs that actually worked consolidated and spread. The lineages that emerged from this crucible became the direct ancestors of today's arthropods, mollusks, and chordates, and the arms race immediately escalated. In the ancestors of modern fish, a set of structural gill arches slowly migrated forward and hinged, creating a new tool for tearing and gripping, the true jaw. This mechanical leap locked the ocean into a cycle of permanent escalation. Peace was no longer a viable biological strategy. From this point on, the history of the sea would be defined by the rise and fall of giants. It is easy to look at these ancient monsters as alien curiosities, completely disconnected from our modern world. But look at your own body. Our eyes, our brains, and the articulated spines that house our nervous systems are the specific tools required to navigate a world of hunters. These traits emerged because the penalty for slow processing or poor vision was immediate. We carry the anatomical legacy of the survivors, the lineages that developed the sight to find food, and the speed to escape the jaws of Earth's first apex predators. We are the living record of the Cambrian crucible.